Hello, this is another screencast on the use of mTree. In this screencast, we'll be looking at the new logging features for experimental data, and then also we'll have a brief demonstration of how to read the output data that mTree produces. So, as I said, we're going to go over the new logging feature. It's especially relevant for experimental data, so this will be separate from message logging and those types of things. We'll also talk about the input style for the logger. So when instead of handing it a simple string, we'll now start pushing JSON into the logging system for at least for experimental data, and then that will become available in the output data files. And then I'll also show you how to use pandas to read the JSON output file and then select it and scan for relevant data. One thing to note before beginning this, you will need to update your installation of mTree. So in order to do this, you'll want to go over to wherever your copy of the GitHub repo is. You'll want to do a git pull, and then at the end of that, you'll actually need to reinstall it using Python setup.py develop. There are some package changes, and you need to make sure that you have the appropriate packages downloaded. So up to this point, when we talk about logging, you had a logging method that you might have been using, and this would simply send data to an output file, and it wasn't particularly useful, especially for the perspective of experimental data. So what we're doing now is we're making available this experimental data logging feature, and so you can continue to use the message logging system if you wish, but now you'll also be able to export out experimental data. So this would be things that you would perhaps run your analysis on. And additionally, it should simplify it and slightly reduce the number of lines of code you'd need to use. So we have that. So the key difference that you'll start to see once you download the new version is you'll be able to execute the log experiment data method just by using self.log experiment data followed by an argument. And you'll be able to do this from any component inside of your MES. So the argument that it has is just a Python dictionary. So it will be converted to JSON at output. So one thing to keep in mind is it has to be a serializable object. So you'll want something that can be converted to text, because JSON obviously stores things as strings. So if you do see some error messages, that will probably be a cause if you have not appropriately thought through your data types. One of the things that this will do, at least currently, it will send all your experimental data out to a file experiment_data.log. It'll still produce things into the mTree log, but those will be more messages in case you're trying to debug things. One of the other things it will also do, if you use the config file and you faithfully use the simulation ID information, that will automatically surface in your data log output, so you'll be able to segregate data based on the simulation run. It'll also provide a timestamp of the event, so that can also be handy. And again, you won't have to actually provide the timestamp. So one thing to keep in mind is the output data. It will be a JSON file that your experimental data log is in. The benefit of a JSON file is it's text and it's readable, it's easily transportable, and it's also easy to store. But then it also allows for unambiguous field separation, whereas if you use a comma-separated value or something like that, you can quickly run into trouble kind of interpreting lines of it. And so in the data output that we'll actually have, it will actually be a file. This is details you might not necessarily need to know, but just in case you look at it or want to edit it manually, it will be a file with JSON objects on each line. So it's a large number of JSON objects, not just one large one. So that can be handy. A benefit of this is actually you can import it directly into pandas, and then you can, after reading it in, you can analyze the contents and separate it by experiment ID or simulation ID or what have you. The timestamp field that gets provided when you use this log feature is in UTC, so you'll want to brush up on that particular time format. It's fairly standard, and if you're using Python, then if you use the datetime library, you'll be able to read it appropriately. Otherwise, you can read it by the normal date functions as well. Like I said, it will also provide the simulation ID and when used, run numbers. So one of the things to consider is if you look at the experiment data output file in its raw format, you'll probably notice that all the events get logged into that file. They are timestamped, but they are not guaranteed to be ordered by the individual components in the experiment. And what this means is if you're running multiple MESs, they might be sending log information at roughly the same time. Thus, you might see experimental data coming from two different simulations that's actually interleaved. So, and we'll show this to you in a moment, but it is something to be mindful of. It's not actually a problem. You will just need to use something to separate out the individual simulation data for analysis. In the future, this will probably go into separate files, but for now, it's in one, and you can use some tools. So it turns out it's very simple to read these files with pandas. All you need to do is import the pandas library, then read JSON, provide it the file name, and then most important, set lines equals true, and then it'll read a JSON lines file. And then once you have that, you can use the standard pandas accessibility mechanisms. So in this case, we're looking at the data and separating it out by simulation ID. Okay, so let's look at how this differs from what you've seen before. So it's pretty straightforward. So if we look at, I believe the environment has one of these, you'll notice that I've just put in some random data here. We have the old style system logging.log where we had to specify the experiment. So that's going away. Again, you can continue to use that if you want to debug things, and that'll be further simplified in a later release. But the key thing is on here on line 19, self.log experiment data, and then you can put in an arbitrary JSON object where you see this test:test. It's pretty handy. If you also look at the institution, you'll see that I just took the item for auction results with the bid information, and you just log that out, and it will actually appear. So how do you run this? So you'll flip to your terminal, and you will, if I do it right, so this will actually run the experiment. You'll notice that it's producing printed statements out. Again, when we're going into certain large-scale simulation runs, this will be slightly different, and we'll talk about that when we get to it. But you'll see the output is here, as it might have been in the past, and then what you'll also notice is there's this experimental data file that's now available. And again, it's all of the experiment data that you logged. So in this instance, it's telling us it's the test message we sent. The simulation ID has been already added automatically. The timestamp is also available. Then these messages here are from the institution. One thing you can do, and it's a matter of preference, you can include the institution, or I'm sorry, the component name, if you wish, in the message to the system that gets actually logged and written out. So you might want to do that just to identify which was the origin of a particular message. Again, it'll be something that we add as a configurable option in the future. Finally, we'll look at the relatively straightforward experimental data reader. And so this is a brief example. If you have pandas, and in this case I stored it as logx for various and sundry reasons, and so it will actually read this file, and then we can show the data from simulation 1 and 2. So we'll flip over and show you what that looks like. So if you simply run the experimental data example data reader, it will run, and then what you should notice is that it's separated out these two simulations by their simulation ID. And then the other benefit too is, and in this case, the messages are not in order, so you'd actually want to sort these perhaps by the provided timestamp. So it is something worth considering. But they are running 2 runs. One has 10, I believe 10 auctions, and the other has 20. So you'll want to consider that. But again, in a relatively straightforward fashion, you can get the experimental data out. All right, so that's what we have for today, and we will continue on with some movements into the UI system in the coming days.